Here's another common example where you're given the magnetic fields and now you need to figure out the polarity of the magnets and which magnets would repel, which magnets would attract. Well, the easiest thing to do in here is to remember that opposite poles will attract. So however the magnets are orientated, if we can figure out the north and south of each one of these magnets, then we could figure out whether opposites are there, and if they're opposite, they're going to attract. If they're like poles, they're going to repel. So if we were to look at the field lines, everywhere you're coming out of the magnet should be north. Everywhere you're going into a magnet should be south. So if we went through each diagram, you could see in diagram 1 we're coming in, so that should be a south pole at this end, and going out at the other end, so that would make that a north pole. On the other magnet we're coming in, that makes that south, going out, that makes that north. Because we have a north-south interaction, these two magnets would attract each other. Go to diagram 2. Again, we have everything going out on the right, so that's a north. Everything coming in on the left, that's a south. On the bottom magnet, we're coming in again, that's a south. Going out, that's a north. So when you put these two magnets together, you've got like poles here, so this would cause a repulsion. What would probably happen if you actually did this and you had powerful magnets, you'd probably see, if you ever played with magnets before, you'd see one of these magnets spin and flip and then come together as a result. They would repel, and if you had a little bit of a torque to this, all of a sudden it would cause an extra force on one end, cause the magnet to spin, and then they would end up coming together. So diagram 2 has a repulsion. Diagram 3, again, we're coming out on the top magnet, left hand side, that's a north. Going in on the right, the bottom magnet, south. Going out, north, and we got a north-south interaction, so these would attract. We already have the answer to the question, but I'll just work out diagram 4 anyway. Diagram 4, we're coming in, so that's a south. Going out, that's a north. Going out, that's a north. Coming in, that's a south, and that'll repel. One other thing that you may be noticing in terms of a pattern here is you'll notice that on the ones that you have a repulsion, you tend to have these spaces of voided field lines where there isn't a magnetic field at some point in here because you've got opposite forces, so objects in those empty spaces would not experience any force. Where when you see the attractions, you tend to see, a nice even pattern between the magnets, and that would show that they were going to pull each other together. It's another thing you can look for. Remember, field lines never cross, and the density of the field lines would indicate where the strongest force would be. So between the magnets, you can see the lines are closer, which would cause a stronger force in between than on the outside. So given the magnetic fields, the magnets would repel in diagrams 2 and 4. So that should be answer D in this case.